Hello Math 2 students. Today we're going to learn how to solve quadratic equations by completing the square. Completing the square is a technique that turns an equation into an equation that can be solved by using the square root method. All you have to do is just replace the c that's there with a c that forms a perfect square. Solve the equation by completing the square. Round your solution to the nearest hundredth if necessary. Don't forget to write this example down on your notes. This quadratic equation is perfectly set up for completing the square. It has an a value of 1 and it has a b value that's even. So now the only thing we have to do to start the problem is replace the c that's there with a c that'll form a perfect square. So 15 is not a perfect square number. We want to move that out of the way and replace it with a number that will be a perfect square. Then we can factor the perfect square trinomial on the left and solve the equation by using square roots. So my first step is to subtract 15 from each side. Now I need to find a new c value that will make a perfect square trinomial on the left. And I'm going to add that c value on in the spot where the c value normally goes at the end of standard form. But if I add the c value onto the left side of the equation, I'm also going to have to add that c value onto the right-hand side of the equation. So now you have to figure out what is the c value that we need to use. Well, you might be able to figure it out in your head, but you can always use this formula. Take the b value and divide it in half. So if we take negative 16 and divide it by 2, we'll get negative 8. Then take your answer after you take the b value and divide it in half and square it. So negative 8 squared, negative 8 times negative 8, is positive 64. So our new c value is 64. And we add that onto the left side in the spot where the c value normally goes, and we have to add the same exact number to the right side, because anything we add to the left side of the equation, we also have to add that to the right-hand side of the equation. Now we need to think of two numbers that multiply to 64, but add to negative 16. So it's going to be x and 8 and x and 8. And because we need it to add to negative 16, we are going to have negative signs in our binomials. And since our binomials are the same, we're going to have x minus 8 squared. And on the right-hand side of the equation, we have negative 15 plus 64, which is 49. So now we're ready to solve this equation by using square roots. If we look at our binomial squared on the left, it's completely isolated. There's nothing in front of it to be multiplied by the binomial squared. There's nothing added on or subtracted at the end. So we're ready right now to figure out how many solutions our equation will have. And if we imagine our next step, we're going to take the square root of the left side to get rid of the squared part of the problem. And we're going to take the square root of the right side, and our radicand is 49, which is a positive number. So we are going to have two solutions. So I go right here and I set myself up to write down two solutions when the problem's over. All right, when I take the square root of the left side, I have x minus 8. And when I take the square root of 49, that could be positive 7 times positive 7 or negative 7 times negative 7. That makes 49. And since I'm going to have two solutions, I have to solve two equations. So my first equation is x minus 8 equals 7. And my second equation is x minus 8 equals negative 7. So I'm required to add 8 to both sides so I can get x by itself. And I'll get x equals 15. That is one of my solutions. So I'm going to come down here and put in my 15. And then if I add 8 to both sides, negative 7 plus 8 gives me x equals 1. And so my other solution is 1. So out of all the numbers in the universe that we could put in place of x to make the left side of our equation equal our right side of equation, we found the only two that can make that happen. Positive 15 and positive 1. Solve the equation by completing the square. Round your solution to the nearest hundredth if necessary. Don't forget to write this example down on your notes. This equation is not really a great equation to start off completing the square. And the reason is we don't have an a value of 1. We normally want an a value of 1 and a b value that's even. So we need to find a way of changing our a value to a 1. So one thing that we can try is we divide every term of our equation by the a value. And the a value will turn into a 1, and the rest of the terms will change to whatever the answer is when you divide that number by 3. But I'm going to start this problem first by subtracting 17 from both sides, because I'm going to clear away the 17. So I'm going to move that c away so that I can replace it with a c that will form a perfect square trinomial. So my new equation is negative 3x squared minus 24x equals negative 57. Now I'm going to divide every term in my equation by negative 3. And the reason I'm choosing negative 3 is because I'm trying to get my a value to 1. I know that negative 3 divided by negative 3 will give me 1x squared. Negative 24 divided by negative 3 will be positive 8x. And negative 57 divided by negative 3 is 19. Now I have that empty space where I'm going to put the c that will form a perfect square trinomial. So I'm going to replace the c that was there, 17, with a c that'll form a perfect square. And remember, the way that you determine which c will form a perfect square is you go to your b value, ours is 8, and you divide it by 2. 8 divided by 2 is 4. After you take your b value and divide it by 2, then you square whatever your answer was. And so 4 squared is 16. So we're going to replace the c that was there with a c that'll form a perfect square, and that is 16. But when I add 16 to the left-hand side of the equation, I need to make sure that I add 16 to the right-hand side of the equation. So now on the left-hand side of the equation, I need to find a pair of numbers that will multiply to positive 16, but add up to positive 8. So that's going to be x plus 4 times x plus 4. And then on the right-hand side of my equation, 19 plus 16 is 35. So back to the left-hand side, my binomials are the same. So I have x plus 4 squared equals 35. And now my binomial squared is isolated. There's nothing in front of it. There's nothing behind it. It's time to figure out how many solutions our equation will have. So our next step is going to be square rooting both sides of the equation. And you can see that we'll have the square root of 35. And since 35, that radicand, is a positive number, we know that at the end of our problem, we will have 2 solutions. So I set myself up for success by giving myself a place to fill in both solutions when I get to the end of the problem. So now we have a little bit different situation than we've seen before. The square root of 35 is going to be a decimal. So in order to solve this problem, I'm going to need to write 2 equations to get 2 solutions, but they're going to look a little bit different. And then I'm going to put everything in my calculator at the end, and I'm going to find out what the answer is. So my first equation is going to be x plus 4 equals the square root of 35. And my second equation is x plus 4 equals the negative square root of 35. Now, you might want to put that in your calculator and get a decimal, but it's not easier. It's easier just to leave it in this form for now. So on the top equation, to get x by itself, I'm going to subtract 4 from both sides, and I'll have x equals negative 4 plus the square root of 35. And when I do the same thing on the bottom, I subtract 4 and subtract 4, and I'll have x equals negative 4 minus the square root of 35. Now, I get a calculator, I plug that into the calculator, and my answer will be And for my second equation, my answer will be, and in the directions, it says to round off to the nearest hundredth if necessary. So that means I'm going to keep 2 decimal places. And both of my answers have a 1, and to the right of the 1 on the outside of the purple rectangle is a 6. Well, that 6 means that we're going to bump it up to 1.92, and we're going to round it up to negative 9.92. All right, Math 2 students, I hope this video helps you to see how to use completing the square to solve a quadratic equation.